So here we need to verify that cosine of 2 theta divided by 1 plus sine 2 theta equals tangent of pi over 4 minus theta. Let us begin. So we'll start our problem from the left hand side. So here we have cosine of 2 theta divided by 1 plus sine 2 theta. Now we know there's a standard formula for cosine 2 theta as well as sine 2 theta. However, instead of straight away using this formula, what we will do, we will convert this cosine function to the sine function in the numerator and this sine function in the denominator to cosine function. So how shall we do that? We're going to use the fact that if we have cosine of theta, so this can be also expressed as sine of pi over 2 radians minus theta. They would mean exactly the same thing. Similarly, if we have sine of theta, then we can express it as cosine of pi over 2 minus theta. However, in the case we have cosine of 2 theta, so if we have 2 theta, this will become 2 theta and sine 2 theta will become pi over 2 minus 2 theta. Okay, so let's use this fact here. So here we have sine of pi over 2 minus 2 theta. We converted the cosine function to its sine equivalent, and the denominator we have 1 plus. Now sine 2 theta can be expressed in terms of the cosine function as cosine of pi over 2 minus 2 theta. Fine. Now we are going to use the concept of the trigonometric ratio of multiple angles and submultiple angles. Now let's say we have sine of 2 theta. Now sine of 2 theta can be expressed as 2 times sine of angle theta times cosine of angle theta. However, we need half of this angle theta. So that means sine of angle 2 theta over 2 will be the same as 2 times sine of angle theta over 2. We have to divide each angles with each angles by 2. So we have cosine theta over 2, which means sine theta will be equivalent to 2 times sine of angle theta over 2 times cosine of theta over 2. Now, if we suppose let theta be equivalent to pi over 2 minus 2 theta, then our numerator is going to become 2 times sine of angle. We need theta over 2, but we are saying that theta is equivalent to pi over 2 minus 2 theta. So we have pi over 2 minus 2 theta. That's the value of theta, but we have to divide it by 2. This factor 2 is also going to come there. Then we have cosine of the angle theta over 2, but theta is represented by pi over 2 minus 2 theta divided by 2. Coming to the denominator, we want to get rid of this value 1. We want to convert this into a single term. So how shall we do that? We know that 1 plus cosine theta, so that's equivalent to 2 times cosine squared theta over 2. However, we have to replace this value of theta with pi over 2 minus 2 theta. That means we will get 2 times cosine squared theta over 2, but in place of theta, we'll have to replace it with pi over 2 minus 2 theta. So we have divided by 2. Let's now simplify. Here 2 and 2 gets factored out. Now we have in the numerator sine of the angle. So pi over 2 divided by 2 will become pi over 4 minus 2 theta over 2 will be simply theta multiplied to cosine of angle pi over 4 minus theta, and in the denominator we have cosine squared pi over 4 minus theta. Now what we can do, we can factor out 1 cosine pi over 4 minus theta from the numerator and the denominator. That leaves us with sine pi over 4 minus theta in the numerator, and in the denominator we have cosine of pi over 4 minus theta. And this ratio, sine over cosine, this is the tangent function. So we have tangent of pi over 4 minus theta, and this is exactly the expression on the right hand side. So hence we have successfully showed that cosine of 2 theta divided by 1 plus sine 2 theta, that will be equals to tangent of pi over 4 minus theta. Hence proved.